Hi everyone, welcome back to One Touch BI. This is Saravanan Vajravel, and today in our class we are going to learn how do we multiply the images using the data augmentation technique. Data augmentation is a special and powerful concept that comes with TensorFlow. Suppose you have a custom trained model that is designed for image processing to predict the images. In order to increase the prediction score of the image, you need to have lots of image samples that needs to be trained. Where do you get the image samples? For instance, I have an apple, and when I just show the apple image right front of the screen, it should detect that it's apple. The apple can be captured either in a bad light or good light, or the image can be either 70% captured or it can be captured 30%. There are multiple options on the image what you have in the hand. So how does it understand that it is apple, though the apple image is not completely captured? So in that case, all possible combination of images you need to produce right front of the screen, and also you need to train that. So in our exercise today, we are going to see that how we are going to capture and generate the images. As you see in the screen, I have used about 8 properties on the data augmentation part. The first property is rotation. As you see any image, you can rotate between 0 to 360. On every call, my image will be rotated, and similarly the width shift. As you see, the image is getting shifted on a width wise, and similarly the image getting shifted on the height wise. As you see that when the image is getting shifted from bottom to top, you see that the bottom scale, the image is getting applied by having a shadow, so that it makes sure that the image is complete 100% accurate. And similarly, a image can have, as I discussed in the previous window, the image can either be taken in a bad light or good light. So all that you should consider when you generate the image samples. That is why the brightness control we have. Similarly, the zoom of the image. As I said, how do I say that I have an Apple image which is only 30% captured? Because the image is getting closer to the camera. In that case, the complete shape of the apple won't be captured. So this kind of images we can generate using the zoom technique. Channel shift and brightness is different. Channel shift is nothing but the RGB scale we are going to vary randomly. As you see, the very first image which is too bright, and the second one is bit darker in the background and getting applied the RGB contrast accordingly, and similarly the other variations. Horizontal flip is nothing but the image what you see in the very first one. You can see that there is a right side one window which is getting flipped in the next image, and similarly it is getting flipped on the other side. So this is kind of getting applied on every call. And similarly the vertical flip, just opposite of the horizontal flip, the image is getting inverse from bottom up to top bottom. I hope you understood now how exactly we are going to multiply the images using the augmentation concept. Without much delay, let's quickly head over to my Jupyter notebook and start programming. Let's start with the command of our program today. It is image multiplier using augmentation generator. Let's import all the prerequisite packages that is required for our today's program. Import TensorFlow Keras processing image, and I'm especially interested with the functions or module image data generator, load image, and image to array. And also I'm interested in image processing with respect to the TensorFlow format. So I'm going to import once again from TensorFlow.keras processing import image. Apart from that, I want to import NumPy as NP, and then I want to import OS, that's for locating my OS level folder navigation to store those images into a specific folder where the images are getting multiplied. And the last but not least, we need import CV2, that's a Open Computer Vision package. And this is the one we are going to use for all our image processing to read and store the images. And also we're going to capture the image using the OpenCV. That is why we need the CV2 package. We have imported all the prerequisite packages. Just to ensure that all this are looking good, you can just execute this code using Control Enter. Okay, there you go. We have made some mistakes over here. So there is no import from, the syntax is wrong over here. So remove the import as we are using the from class, because we are going to import a specific module from the TensorFlow Keras pre-processing image module. We have corrected the code, just execute. There you go, we are good. And move on to the next cell. Here we are going to define the augmentation properties, that how we are going to generate the image. As I shown in the slide, we have to define the rotation, width shift, height shift, etc. So let's comment data augmentation configuration. And the augmentation configuration we can define using the image data generator. So here is my definition. Image data generator, and here I'm going to define the rotation range 360 degree. That means I'm going to rotate all the way from 0 to 360. And the width shift range, I'm going to keep it at any time 0.1, because that makes accurate for my design. Height shift configuration similarly 0.1. Brightness range 0.5 to 0.9, because anything below 0.5 is going to be complete block and doesn't make sense. Zoom range I'm going to keep 0.6 to 1. 1 is the max, 1 indicates 100%, and 0.6 is 60% to 100%. I'm going to zoom in, zoom out. Channel shift range, I'm going to keep it 100%. Horizontal flip true, vertical flip I want true, and the fill mode, whenever I move the horizontal flip on vertical flip, that remaining images, what you see in the bottom, that gap, that I want to fill some constant value. That's why I'm keeping it constant, so that the blurry part won't be there. And the rescale, I'm going to keep it 1 divided by 255, because in the TensorFlow, all your images to be scaled within 0 to 1. And I want to assign the image data generator to the variable called train data gen, so that I can later use that for rest of my call. So let's assign to the variable train underscore data gen equal to this. We are good. Let's execute this. It got executed successful without any error. We are good. Let's move on to the next section. Let's make a block commented for our reference. Image multiplier built-in camera. We are going to capture the image using the built-in camera from our laptop. Before we proceed writing the source code for image capture using the built-in camera, we need to define where exactly we are going to store the sample images and the test images and train images. So those file paths we need to provide. So if you see in the Windows Explorer where I'm going to keep all my source images, the sample images I'm going to capture under train data set inside the folder called samples, and similarly the test images will be kept under test folder and train images will be under the train folder. So without much delay, let's define the paths. Here are my paths. The dataset configuration path. The train path is going to be from the directory that I showed. I'm going to store inside images train data set under the train folder. We are good. And similarly, the validation path is nothing but the test folder. So this is again good. And my samples supposed to be inside the train dataset samples folder, which I'm going to modify now. This should be samples. That's all. We have defined our dataset configuration path. Now I need to define what is that the class name or the product name that I'm going to capture using the built-in camera. The class name is nothing but my folder name inside the train folder, test folder, and samples. Create class name directory, and the class name I'm assigning, I'm going to capture Pringles and followed by the -99 that indicates the product price of the Pringle. Okay, we are good. The next section, what we need to do is we need to create the class name, the product name folder inside the train path, val path, and sample path. When you attempt to create a folder, if there is any syntax issues, it may throw the exception. So it's better to write inside the try and except block. Try, and I'm going to create a folder. If the folder already exists, it should skip it. os.make directories, and inside the make directory you need to provide the path where you want to create the folder. So what is the path? It is a train path plus you need to provide the folder name is called class name, and if the folder already exists you need to skip it. So exist, okay, equal to true. We are good. Repeat this command for the remaining two. For the samples it is not required. Let's remove it, and now this should be changed to val path, class name. We are good. In case if this throws exception, we need to capture the exception, accept OS error as error, and print the error message. The directory cannot be created, and the %s is going to be replaced with the folder what we are intend to create. We are good. Now we need to initialize the video capture using the Open Computer CV package. Let's comment it. Capture image and generate data augmentation for train or test. Here I'm going to initialize the variable called video capture, and this is nothing but cv2.video capture. In general, most of the laptops will have a built-in camera identified with 0. If in case you have an external camera configured or by connected with USB cable, try changing this number 1, 2, and that way you can come to know which camera has got initialized. For a built-in camera, you can go with 0. We are good. We have initialized the video capture. When you initialize the video capture, I'm not sure where exactly my camera got positioned. So in that case, the very first shot is going to be a kind of dummy, which is to make sure the position where exactly my camera is pointing. So the first one, I need to keep it kind of dummy. So in that case, I want to make a for loop to repeat for 6 times, and the first frame is going to be excluded for I in range of 6. I want to extract the video capture that is initialized to read the first frame. What is our variable name here? Vidcap.read of, and this is going to return at any given time two parameters. The first parameter is return whether it is written true or false, and the second one is going to be an image. As I'm not interested on the first parameter, I can just go with underscore. That means I'm going to omit the first parameter, and the second parameter is nothing but my image. That's it. Now the image has been captured, the very first image, and got assigned to the IMG. As and when I capture the image, I need to store the image into the samples path. Store the samples. Using CV2IMWrite, I can store the image that I captured using the video capture read. And CV2IMWrite is going to take two parameters. First parameter is the file name and location, and second parameter is the image that I'm going to write on the specific URL. We are good. We have captured the sample image and stored into the system. After I capture the sample image, I want to ensure that in the screen how many images it got captured so far, so that the end user is going to aware that, okay, I captured one image and I captured second shot and third shot and so on. So let's make the counter display on the screen. Using the cv2.putText, I can go and display some caption on the image that how many images I captured. Captured followed by the format I'm going to replace with I. In case of very first image, it is 0, and from there it should go until 5. So it is going to be printed, and this one getting replaced with open and closed flower bracket. And the exact X and Y coordinate where I'm going to print the captured label at 10, 30, that is X, Y, and the font I'm going to use CV2 font Sleep Line, the default font type. And this one is going to indicate what is my thickness of the font, and this one is going to define my color of the font. In my case, I'm going to keep it 255, 255, 255, that indicates white. And the last parameter is the thickness, and this one indicates the font scale, whether you want the font size to be 1 or 2 or 3. Okay, now we have given the caption for the display. Now we need to show this image what is being captured to the end user. How do you show that? Using cv2.imshow, and you need to show the window title is called capture and display the image. The image is now going to have image along with the caption what you have printed here. Using the cv2putText, we are good. Now you need to move on to the next image until you press some key. How do you do that? Using cv2.wait of 0. As I said, when you capture the very first image, you're not sure where exactly your frame is located. So we need to skip the first frame. Skip the first image for ensuring the camera position. So I have to omit the index I equal to 0. If I greater than 0, only then I should consider capturing the images and putting into the train and validation path. As I have already captured the sample image and stored into the sample path, now I'm going to load the sample path image, and from there I'm going to multiply the image. So in order to load the sample image from the sample path, we have already imported TensorFlow load image module. So I'm going to load the image from the sample path followed by class name and the JPEG, and that I'm going to assign it to the variable called img. After I load the sample image, I need to convert this image into the array format. Converting the image to array format, img array equal to img to array of img. img to array is an built-in module what we have taken from the TensorFlow Keras preprocessing. Using that, passing the image what you have loaded from the sample, it will convert to the array, and that I'm going to assign to the variable img array. In order to represent anything in the TensorFlow format, the image should be read in 4-dimension. So converting into 4-dimension array, we have a NumPy module. Using the NumPy module, we can expand the dimension to the 4-dimensional array format. So now let's assign this output to the image array. The np expand dims is going to expand the image array into a 4-dimensional array format, and 0 indicates the axis to read whether horizontal or vertical. So we are going to read here in horizontal. So 0 indicates horizontal and 1 indicates vertical. We are good. Let's generate the train data set now. Generate train data augmentation. So we are going to call the function generate image, and I'm going to pass the first parameter image array that we have expanded into 4-dimensional array format. And I'm going to store these images into the train path plus the class name, the folder, and the class name is the one which I'm going to prefix for each image that is getting generated, and every image shot that I'm going to capture on 5 times using the Windows built-in camera. Each shot is going to generate 25 different augmented images. So on the train data set, I'm going to capture 5 times 5 into 25, 100 images. And the test samples, the same, let me copy. And this one, I need to repeat 1/5 of the train data. That means 5 test samples I'm going to create it. And you know the path for the test samples is validation path, and exactly same. And let's provide the caption. We are good. And what else next? We have to release the video capture, as well as we have to release the cv2 destroy all windows. So let's put that cv2.destroy all windows, and video cap.release. It's going to release the video capture. Let's name this release all windows and video capture. Okay, are we good? No, we need to define the generate image function, where exactly we are going to control on generating the 25 samples and respectively for the test data image 5 times. So let's define this function. After we define the function, we are good. We can just execute and see the output. Okay, without much delay, let's create a function generate image. Copy this. Just above this image multiplier built-in camera module, you just insert a cell above. So here is my generate image function that starts with def syntax, and the first parameter that I'm going to pass image, and the second parameter that is train path followed by the class name folder, and similarly for test val path followed by class name folder. That's nothing but save to directory, and every image that should have a prefix of the class name. So the third parameter is the class name, that is called here as save prefix, and the fourth parameter is the save format. Whether you want to save the image in the .jpeg or png, I'm going to save as JPEG format, and the fifth parameter is the count, n. And in the very first time, the count starts with 0, and I'm going to repeat the train data gen, which is nothing but my image data generator initialization variable called train data gen. This has multiple modules. The flow module is the one which I'm going to use the image what I captured from the built-in camera and passing one after another image, and based on that I'm going to generate the images. And inside the flow we need to pass following parameters. The very first parameter is X, that's nothing but in our case the image array. And whatever you have the remaining parameters with equal substitution, that is going to have a default substitution embedded. You don't have to specify. If you specify, it will override that assumption. So in our case, the second parameter is save to directory we are using it, where exactly the images should be saved. And save prefix is nothing but my product name or the class name, in my case the folder name. And the save format is nothing but my JPEG format. And I'm going to increase the count within that for loop. So as I have passed the count as 25, this image should be generated using the augmentation property until first 25 images. So very first time it was 0, and inside the for loop I'm incrementing after I save the very first image, it becomes 1. Is it 1 greater than 25? No. In that case, it will be keep repeating this for loop. And at a point where it becomes 26, 26 greater than 25, yes, and that moment it's going to break the for loop. So after it got generated 25 images, it will skip the for loop. So similarly, I'm going to call the test data augmentation. We are good. So in this case, I'm going to capture a mouse instead of Pringles. That's my class name. So I'm going to rename my product name as mouse, and the cost of this wireless mouse is $3.99. Okay, so this will be easy to identify a product with the price. Okay, as I have added the function generate image, I need to compile this. How do I compile? I can compile using shift plus enter, and it will move to the next block. Just make sure that it got executed successfully. We are good. And now we are going to run the last block. What we have done now, it is going to create a class name mouse 399 into the path what we have defined, train path, validation path, and it's going to repeat the for loop for in range of 1 to 5, and the 0th frame will be skipped, and it's going to repeat that data generator for 25 times for the training data images and 5 sets for the test images. Okay, let's run this code. Here we go. We got captured the image 1, the reconnect mouse, and let's go to the folder where exactly we created the image paths. It's inside images, train data set, inside samples. I should see the image mouse 399. The sample got captured. And also inside the train mouse 399, you should see around 25 samples to be created over here. Click on the mouse button to move on, initiating the 25 samples to be created inside the train folder and 5 for the test folder. And it is now moved to the second image to capture. So now let's go back to the source drive. Now you see that under the train mouse 399, 25 samples got already created. 25 means it's not going to create 25 exactly. In some cases 25 and some cases 24. The plus or minus 1 will be there. So it's not going to be accurate, but yes. As you see, the first image got created 25. And you can take a look. It got flipped, rotated, and applied all the brightness and the channel settings, everything got applied. You see that? I'm just keep navigating to the next images. You see that that mouse has been captured in all different possible directions. With just one single image, I was able to generate 25 samples. Okay, now it is moved on to the second frame, and in the second frame, this is my sample image, and now this will further create another 25 sets. When I press on the spacebar or any key in my system, you see that the image count is increased. Now we have total 49 images. Now we move on to the fourth frame, and it got created another 25 set of images, and the last frame, the fifth frame, and there you go. And now you can see that in the background there are 99 samples got created with just 5 shots of images. And let's navigate into the test folder. Under test folder, now mouse 399 will be captured around 25 samples. That means 5 times we captured 5 into 5, 25. We can take a look here. These are all my test images. See how simple it is. I just captured using my built-in camera, one single click. It got created parallelly 25 different samples on the train dataset and 5 into the test folder. And on the next click, again another 25 samples on the train and 5 samples on the test folder. This way we can multiply the source images into multiple samples that is required for TensorFlow Keras image processing. With this, I'm going to end this recording. Until I come back with another interesting technical video, this is Saravanan Vajravel signing off from OneTouch BI. Have a good day and take care.